Okay, so my name is Antonii Sirotsinsky. I'm a Golang developer in Agiliway, and today we're going to be talking about automating deployments of your Golang projects to AWS, and we'll be using Serverless framework for that purpose. So let's go quickly through the agenda for today's meeting. We'll start with a quick introduction to the serverless framework. Then we'll see what prerequisites you need to deploy your application to AWS or any other cloud provider with serverless. Then we'll set up a simple local serverless project. We'll see how you can deploy AWS Lambdas with serverless. Then we'll take a look how you can define environment configurations for your project, like for separate configs for environments. Then we'll see how we can reference existing like pre-created AWS resources in serverless, and we'll end with the with a simple GitHub action job that will help you to deploy your resources to AWS like remotely. So first of all, what's the serverless framework? What is that? It's open source YAML-based tool, and that tool is helping you to deploy your cloud resources to cloud providers such as AWS. Like I see a few advantages in using the serverless framework, and the first of all, it's super easy to use, and it's powered by AWS Cloud Formation. What does this mean for you, like for a developer, like a project owner? You do not need any additional servers set up like you have for Terraform. You don't need to like as a developer do not need to learn any additional languages, configurational languages, etc. Because that's all YAML based, and under the hood it's running the AWS Cloud Formation command, so you do not need anything except basically the AWS. Then it's cool because it allows you to keep your infrastructure and code all together. That makes the changes much simpler. Because you can do it like in one place. Then really big plus of serverless, you can deploy like any resources to, for example, AWS, like Lambdas, API gateways, secrets, IAM roles, like anything you name it, you can deploy it through serverless. And it's super easy to set up the environments. We'll talk about that later. And it's language agnostic, meaning that it basically doesn't care which language you are writing on, because it doesn't depend on that. So let's see like what prerequisites you need to be able to deploy your projects with SLS to the AWS cloud. First of all, you of course need your AWS account created. Then you need a IAM user and role with sufficient permissions created. And by sufficient permissions, I mean like if you want to create the Lambdas and API gateways, of course your user and role should be able to do that. And we won't be doing that. This is out of scope of today's presentation, but it's super easy to set up in AWS. And you are gonna need a couple of tools installed to be able to like work with AWS and serverless resources. So you would need AWS CLI and serverless framework itself installed. Yeah, so let's actually see how can you set up a serverless project locally. First of all, you would need to run AWS configure command here in your terminal. So let's go here and do that. Let's run AWS configure. What this command does, this like kind of signs you into the AWS your AWS account, your user, you should provide your access key and secret access key here. I already done that, so I won't be doing that now. I'll just skip these steps. It also asks you for your default region to deploy your resources to and the output format. Yeah, you should just basically enter your access codes you have from your user that you have created in AWS. And once we are logged into the AWS, we can start our resource creating. First of all, let's see how would look like the easiest, the simplest serverless file, how it looks like. So here we have the template on the screen. Then the first line is like we just defining the our service name or the stack name. That's like the terminology of the AWS. I'll show that a bit later. So here we are providing some information about our cloud provider. In our case, we'll be using AWS with US East 1 region and providing the runtime configuration we are planning to use. So in this case, I'm using provided Amazon Linux 2 because it's recommended by AWS for your Golang applications. So let's go ahead and create that in our project. So let's do services folder and serverless example file. So this file can actually be named as you wish, but by default, the SLS framework will be picking up the serverless YAML file. So let's use that for sake of simplicity. Okay, so here we have the basic file, basic serverless configuration, the same we saw on the slide. And actually, this is basically enough to start your cloud deployments. You can now run SLS, it's short for serverless. You can run SLS deploy page dev. And yeah, you actually have to run that from the directory with the serverless file. So let's go to this directory and do that. So we see that serverless framework started to do some work for us. It's creating the cloud formation stack. So let's go to AWS and see what's actually going on here. This is the cloud formation service from AWS. And like this is basically the thing we are using under the hood of the serverless. So we are running the commands on this service, and it will be creating resources for us. So we see the stack, some stack creation has started. This is named Hello Service Demo Dev. We see the name here is Hello Service Demo, and the stage name will be used as a suffix for your resource, just so you can like differentiate the environments. Okay, we see the service was successfully deployed. Let's go and see what the status here. It should be, yeah, it's update complete. We can open this stack and see what resources it has created for us. We don't have much resources here yet because we haven't actually defined anything, but we already see that some deployment bucket and bucket policy was created for us automatically by the serverless framework, and and this bucket will actually be used to keep your your configuration of your resources that was created by serverless framework. Yeah, so this is the most basic resource you can create using this serverless. Okay, so let's go and see what actually useful work can we do with the serverless. So let's see how can you deploy the AWS Lambda with serverless, and I really like Lambdas especially for starting of some small projects or like even mid-sized projects, because you basically do not pay anything for Lambdas if those are not executed often. So yeah, and with Golang they are running super fast, so that's cool. So let's go ahead and create the Golang function, like some service that we'll be deploying with AWS wrapper. And in order to do that, first of all, you would need to get AWS Lambda Go package. This is needed because it has like basically super useful tooling for working with AWS Lambdas. So let's go ahead and do that. Yeah. So yeah, we have added the Lambda to our Go mod file. Let's create some new service here. So let's create some hello world with main file in the main package, so it's executable. Let's create main. Yeah, and actually, one thing about AWS Lambdas, AWS requires you that you should use the lambda .start as an entry point for all your Lambda functions. Without that, your Lambdas won't work, and your handler function can be defined separately, just so it's like easier to read. So what this will do, this will just basically execute this handler with the parameters provided from outside and like return the results to the outside, like to the caller. Let's do some basic print here. Okay. So after we have written our Lambda, we have to build the executable for that Lambda, like build the artifact, and we can go ahead and deploy it. So how would we build the Lambda? We're basically doing the standard Golang build. Just a second, I have to move this thing. Okay, so we would normally do just go build to get our executable. Sorry, copy that. Yeah, but since we are building for the AWS and we'll be using like Linux there with the ARM64, we should provide additional arguments to our build. So let's do the build, and also we have to package our Lambda into a zip because the AWS allows you to like package your Lambdas in two ways. The first one would be the containerized image, and the second would be the zip file. So let's use zip for this example. Yeah, so we see we have built our executable, we have packaged it, and now we should provide, basically say to serverless that we want to deploy our function inside of this service or this stack, as it's named in AWS. So let's go ahead and add some functions here. I have a sorry, some template for the function created. So yeah, here we are saying that we want to create a hello world function named, let's name it hello world as well. We said we will be using ARM64 architecture, and we'll need to provide some packaging details here. So since we're running, like we already know, we need to upload and use this package, but we are running this from the serverless frame or serverless like folder. So we will need to do the hello world zip to access this file. And then we're saying we want to package the Lambdas individually, not like the whole stack all together. And the handler would be like our handler name here. So that's basically the information that serverless needs from you to be able to deploy. So let's go here and rerun our SLS deploy again. So we saw just the serverless was retrieving our existing stack, and now we, because the stack was already created on the previous step, and we uploaded our zip file, and now we are updating our CloudFormation stack with new resources. So if we go here and see the events, we see a lot of resources started creation. And what's interesting here, we are, so let's go to the resources tab. So we see the log group was created automatically for our Lambda. So that will be used to, like, when you print, like, produce any logs, that will be stored in the log group. Also, the IAM role was created for your Lambda, so your Lambda can be executed with that role. And yeah, I refer this, so we actually see the function also has been created. So let's go ahead and see the function. Yeah, so we see this is our basic function. Our code was uploaded here 25 seconds ago. We chosen the Linux 2 runtime with the handler of hello world. Yeah, and let's go and trigger basically this Lambda here, because right now we haven't specified any other triggers to this Lambda. So the only way to trigger, like execute the Lambda, would be to do that from the AWS or from the CLI. So let's go ahead and trigger this, and oops, it failed. Yeah, but don't worry, that was expected, because I wanted to show this error, because this was really frustrating for me when I just started with AWS Lambdas. And so it says you have invalid entry point, and it couldn't find any any bootstraps. So what does it mean? If you go to AWS documentation, let's open that. Documentation for Lambda packaging, we would see that, yeah, we have to create a zip file. We've done that. You have to use the AWS Go Lambda. We've done that as well. And we did a build properly, but you should always name your executables as Bootstrap. That's a requirement from the AWS, and we haven't done that. So let's go here. So what does it mean? That means that when we are doing the build of our application, we should provide -o and the name of the handler. That will be a bootstrap in our case. So let's drop this. It's not confusing here. Yeah, so we'll create a new bootstrap handler here. After that, we can zip it the same way we've done before, but with the bootstrap name. Yeah, so the handler, sorry, the artifact can be named still hello world, but the handler under this artifact should be always the bootstrap. So this should also be named the bootstrap. So let's go back. So let's rerun the deploy again. Yeah, and actually, it's pretty annoying to do this, like builds and deploys and stuff. So it will be useful to create some deploy, like build and deploy script to encapsulate the stuff we've just done here. Yeah, so let's create a build sh script here. Yeah, so we're essentially doing the same thing we've done before. We are building the bootstrap, making the package of that, and deploying it using the SLS deploy command, and some stuff for working with active directories. Okay, now we see the service was updated. We can go to our CloudFormation. Even let's go to the function. Let's refresh this. So we'll see the function was updated. Yeah, it was updated 39 seconds ago. Let's go ahead and trigger this now. Yep, and now we see our Lambda succeeded. It hasn't returned any details, but that's expected. We haven't returned anything, but we have printed the logs here. And that's cool. We have our Lambda deployed, and it took really like small amount of time to do that. So we deployed our Lambda, but as I mentioned previously, there is no way to trigger your Lambda yet from the outside world. So let's go ahead and add the HTTP trigger and handle the HTTP request response, because I think that's like the most common case for the Lambdas. So let's say we'll be returning the API gateway response, and we'll be handling the API gateway request here. And actually, the AWS also requires you to always implement the error interface. So you should always return the error in addition to like the parameter you return here. So yeah, request response. So let's return something. Gateway response with some status code 200 and the body of yeah. So we have updated our Lambda to handle request and response. So actually, let's go and update our configuration so it's aware we are expecting some triggers. Because right now we haven't defined any triggers in Lambda. It named like the events. So for the events section, you can define like any number of triggers we want to. So let's in this case define HTTP API. With the we also have to specify the method and the path for the API. Okay, so we are saying we want to trigger this Lambda with the HTTP event, and let's also add some path parameter here. We'll be accessing this path parameter using the name keyword. So let's go here. We have this event incoming parameters. So let's do some println here with configurable value here. So let's access this event. Yeah, so we see this event. In this event, we have the access to the path parameter body cookies, like all the normal HTTP attributes we have. So we can access these path parameters, and we said it would be named as a name. So this is the keyword we will be like mapping. Yeah, same way you can access query stream parameters if you want to, but let's start with the path parameters. Yeah, let's go here and execute our build script. Yeah, so we can retrieve in this cloud formation stack. The serverless will see that we have updated our template. We have added this event section, and it will create some new additional resources for us so that we would be able to handle the HTTP requests. So let's go see what right now in our Lambda configuration, we have no triggers, but after this update is executed, we will see that the new trigger of API gateway will be added to the Lambda, and in addition to that, a new API gateway will be created for us. So yeah, we have the trigger, and actually, if you go to your deployment, we see that serverless tells us, okay, you have deployed the resource, and here's the URL for that. So let's go and execute it. And if you provide some information here, it will be returned in a result as we just configured. So yeah, we can see that in this API gateway, We have created some simple routing for the hello world and the get method, and we have the configuration, the integration added. And in this integration, we see that we have linked kind of this route to our Lambda function. So of course, it's not the only type of trigger you can use for your Lambdas. You can refer to the documentation. By the way, Serverless have some really great documentations. You can see that you can handle requests from like IoT devices, like the CloudFront, all the kind of queues, Kafka, all that good stuff. You can also like have some cron jobs defined super easily. Yeah, and for example, as I mentioned previously, you can have multiple triggers for your single Lambda, and you can, for example, say that you want to run this Lambda on schedule, and the rate would be 1 minute. So this way you can create kind of cron job that will be run every minute, and this is in addition to like your manual triggers from the API. Yes, so let's proceed with our presentation. Let's now talk about environment configurations. In serverless framework, you have some environment variables that you could use out of the box. This is like some, for example, for AWS, you can use some information of your account, your region. Even you can access the some secrets from the AWS. I know some people sometimes some people like store the configuration parameters in the secrets. So that's also available, and you can like use those. But here I wanted to show you how you can reference the properties from external files. That's like the easiest way to do the configuration work for your project. For example, let's go here and create a config directory. And let's say we want to have 2 config files, dev, YAML. And in dev YAML, let's say we want to have environment, and the name will be dev, and the, for example, Lambda section will have the timeout. Let's say for dev it will be like 10 seconds. Let's copy paste that for QA as well. And for QA environment, let's say the timeout will be 20 seconds. Yeah. So now, how can we use these in our serverless configuration? You can super easily add some environment variables to your configuration, like environment, and for example, you can name your environment, custom environment variable like that. And let's access here the env.name. So this is kind of the this section, this subsection. So that would be our env.name, and for timeout, let's specify this property now. Like before, this was just like some default value. It was set to, let's see, yeah, to 6 seconds. And let's now use the configuration. Yeah, and let's try to deploy these to QA environment now. So in this build script, we specify that we will be deploying to dev. So let's change this now to QA. And let me explain you how this thing works here. So we are saying this environment name, like this environment variable, the value of it would be provided from the config file. And this config file will be in config folder, and the name of it would be, it will depend on the stage parameter we are providing here in the SLS deploy command. So you can imagine, like, for like, you can have some GitHub action or like a couple of actions, and either it will be like parameterized deployment where you like specify the thing, or you could just have like them separated. Doesn't matter. Yeah. So you would access these two files depending on the stage that you are providing to your SLS deploy command. So let's go to our function here and use that value somehow. So let's say you want to access environment variable, and that will be in the name. Yeah. So now we'll see the log should be changed. And one more note here. As I mentioned, when you are providing a stage to your build command here, that stage value will be used in some resources. For example, as we saw for our stack, it was created with hello service demo dev name, but it won't be used for all the resources that you really kind of specifically say into serverless framework you want to provide your own value to. So, for example, we have this function, hello world, and we are saying the name of the function of this function should be hello world. And the stage won't be like participated here in the naming, so we can do that manually now. We can rename this function and say that now it will be like hello world -dev or QA depending on the stage. So let's go ahead and try the QA deployment. So now we should see the new stack will be created. Yeah, we're creating a new stack with hello service demo QA name. Let's go to our stacks. Yeah, we'll see these new stack creation has started. We'll do essentially the same we've done with the dev deployment, with the only difference that now we'll be renaming our Lambda bit and extending some configuration. Oh. Yeah, so we see this stack was created. Let's wait a bit for the Lambda to be created. And for example, our old dev Lambda and like dev resources, of course, won't be changed because we haven't done anything to them. We are specifically deploying the QA section, QA environment and stage. But just so you know, we can go here in this existing Lambda. There is the environment variables section. Right now we see it's empty, but in our new Lambda, the QA, yeah, hello world QA Lambda, we now should see that environment variables. Yeah, we have provided the env name to be the QA, and that will be used later in our code. So, okay. Yeah, we see the new API gateway, like new URL was created because previous one was one we see, and the second one is this one. So let's go here. Yeah, we see that our Lambda was updated. We have this value accessed here. And yeah, and we have successfully updated our project to be the stage related. Let's go ahead and redeploy the same to dev. So we have all of the stuff consistent. Yeah. So while we are doing that, let's go back to our presentation. So up until this point, we have talked about creating new resources in serverless. and it's cool, good, great, but sometimes you need to reference existing resources. For example, in some situations, when you need to maintain like a higher level of stability and consistency, you need your IDs of your resources to be more static. For example, if you are like integration between teams and you are like creating some buckets in serverless, or like maybe not buckets, but like the API gateways, and somebody will be using that. And if you decide to delete and recreate your source, the IDs will be changed. So the collaboration can be broken a bit there. Also, if you want to avoid some URL changes and downtime, because as you have seen, the API gateway, when it gets created, you see that the URL is using the IDs. So it's like randomly generated IDs. And if URL, of course, changes, your clients won't be able to access like the old ones. And of course, if you create less resources, like if you reference existing API gateways and you are not creating the API gateways, you don't need those permissions. So that's also a good thing, especially if you configure like some VPCs or IAM roles, or stuff like that. So let's see how you can reference existing resources. Here I have these API created manually. I can just copy this ID of this API gateway and go ahead and update my configuration. So now we'll be saying that we won't be using the API gateway created by the serverless framework, but we want to specify our own. So we can do it like that. And that's basically it. We don't need anything else. So right now, for dev stack, we were using this one we see URL and the API gateway. And after this change, the serverless frameworks should see that we specified the API gateway here already, and it was created manually. So now we do not need it to create for this HTTP API. We do not need it to create the API gateway for us, and we just want to reuse the existing one. Okay, we see that we are updating the stack. So let's go to the dev function. It was updated just recently. And under the configuration and triggers, we should see that now the API endpoint was changed accordingly to the API gateway we provided. Yeah, so this is the ID we used, and this is like the API gateway URLs. It just resolved that URL by the ID, and of course all the functions should work the same. Okay. And the last part of things I wanted to share with you today, it's the automating deployments of the serverless resources with GitHub Actions, because it's nice to be able to deploy your resources locally, but of course you at some point you want to automate that. You want to somehow trigger the builds and deploys on some merges, on release creations, or on any like on any repository action. So in order to do that, of course you still have to deploy resources. So you have to use your AWS credential, the same you have used locally. You can use them as a secret in your GitHub repo. I've already done that, so we won't be doing it. And this is needed for this configure AWS credentials action. And this action will actually log you into the AWS. It will assume the role we have created on like as a prerequisite for this. And it will be deploying your resources using that role. And of course, you have to install some dependencies, same way you have done locally. So let's go here and add the GitHub in the workflows. And I have some template created for these, like some simple workflow. Okay, so let's go through this workflow we have here. We essentially will be triggering that manually. We are going through these steps, like checking out the branch we'll be using in our when running the GitHub action. Then we of course need to install the SLS framework in order to be able to execute the SLS commands. And after that, you need to use the job I mentioned in order to log into AWS. It just simplifies the login process. Of course, you can do that like manually. Yeah, and we are saying we are providing these GitHub secrets. I have exported in advance, so this is essentially the same secrets you have used to deploy locally. And we are saying we will be using this region and assuming the role for the deployment and some session configuration. And after that, we're just like executing our build script we have defined here. So let's try to do that. It's stuck a bit, I guess. Let's just stop it. Yeah, so in the meanwhile, let's continue. Yeah, doing some checks already. So while it's doing these checks, let's see how, like, what conclusion can we do from today's webinar. So as you saw, the serverless framework is super easy and fun thing to use. It really simplifies the deployments to AWS without you needing to like learn some new configuration language and set up a lot of additional resources. It's free and open source. It has really good community support. You can like basically Google all the troubles you have during the deployments with serverless. But of course, it's not like a silver bullet. You have some limitations, like for example, for the complex resources, SLS may not be like the best solution because when you are trying to do some stuff like we want to have really different rules for some specific conditions, environments, and if you are like defining complex resources, the configuration can get a bit messy. So the thing I mentioned then, that when you're deploying your static like core resources like VPC or API gateways, it can like the IDs can change. So I guess like the best solution would be to kind of mix these. If you have like a big project and you really worry about these resources, you can use a mix of different tools. So with some tools, you will be defining, or either manually or with the Terraform, for example, you'll be defining the core configuration that won't be changed recently. And with serverless, you can just define some Lambda functions, some smaller things that you will be like you expect to be changing more often, and that change should be much easier. So let's try this again. Yeah, so let's go to our project here. So we have our deploy workflow added. So we can just basically choose our branch, have only one here, and execute it. So essentially, if this is if this job succeeds, I'm not sure about the AWS credentials here. It will just do basically the same. It will try to redeploy our resources we already have deployed to the environment. The stuff we've done locally, it will be basically doing that in GitHub Actions. Yeah. So we see the configured credentials succeeded. That means like our credentials were correct. So now we are doing basically the same stuff we've done locally. So after this job runs, we should see at least the last modified timestamps to be updated here. Yeah, so we see the code was updated, and we've done it basically from the GitHub Actions and not locally. And that is it. Thanks for listening to this presentation. Thanks for joining, and let me know if you have any questions. We'll be happy to hear those.